Hi class, now that you have turned in homework from week 4, there are a few points that I want to go back over to make sure that you didn't miss. First, I want to talk about the jet stream. Now, the big thing that you need to know about the jet stream is basically it's the boundary between cold air and warm air. Now, during the winter months in the northern hemisphere, it is further north. You would expect to find it along the U.S.-Canada border. And it's usually pretty straight. There's not as much waves in it during the summer months. Now, you should realize by now that the jet stream drives weather systems across the U.S. And so when it's in a nice zonal flow, there's not much change in it. The weather is persistent. A lot of times we'll get these high pressure areas sitting up and it'll be sunny and hot for days at a time. Now, come in the winter months, there's much more of a wavy pattern, then it moves more south. Looks something more like this. See how much further down the jet stream dips during the winter? And all that cold air from Canada deeps down into the United States. And as a result of that, we get these low pressure systems. We get cold fronts and warm fronts, stationary fronts sometimes. But much more active weather during the winter months, generally speaking. Obviously, there's going to be exceptions to that, but that's a lot of times how it is. So those are the main things that I want you to know about the jet stream. I also want to move on to highs and lows. Now, these can be complicated, but we want to make it as simple as possible. First, let's just concentrate on highs and lows at the surface. Since that's where we are, that's what we experience. It's just more tangible. And as we learn more about it, we'll move up higher in the atmosphere and find out how, if that's changing, how that's going to affect us here at the surface. So I'm going to use this slide. I wish I had a better one, but this will have to do for now. Start with a low pressure area. Obviously, when there's low pressure, basically that is sucking in air. You got higher pressure around it pushing towards this low. So it's drawing air in. And air circulates cyclonically or counterclockwise around the low pressure area. Now, let's look at the high at the surface. In a high pressure, air is circulating anticyclonically or clockwise around a high. Now, a high pressure is much more spread out. The isobars are spread out, and that tells us that the winds are much lighter. With a high pressure, we expect fair skies, either clear or a few thin clouds, as opposed to we do expect clouds from a low pressure area. So let me move on to the next step. We'll come back to that slide in just a minute. Trying to figure out the easiest path to get to learning all that we need to know here. Let's use these wavy lines that I've drawn to imagine these are contour lines from an upper air map. Now, contour lines are very similar to isobars at the surface. They're called contour lines because they actually measure the height at which, say, 500 millibars is measured. But you can think of them as the same thing as isobars. Now, we see this wavy pattern. It's wavy because we have a high pressure here. Notice the winds are going anticyclonically over high. You have a low pressure north of these contour lines. That's what's pushing it down and making it curve this direction. And again, a high pressure, and we curve this way again. Now, the winds, generally speaking, flow parallel to the line. So you're going to get the same curvy pattern as you see in the contour lines. That's how we know what direction the winds are blowing. Now, ridges and troughs. The whole class had some issues in figuring that part out in problem number 2 in chapter 8. So I want to go with that a little bit. Ridges and troughs, both, they pass through contour lines. Basically, they're perpendicular to the contour lines or the isobars, whichever we're looking at, if it's an upper air map or a lower. Again, this would be like looking at an upper air map. The bumps, the higher part, that's your ridge. Okay, don't make it complicated. We just look for the humps. So this would be a ridge here, and this would be a ridge here. Notice they're associated more with a high pressure area. The trough is your valleys. Again, it crosses right over the contour lines, and it will have to do with a low pressure area. That's why we get a trough. So now let's look at the up and down pattern of the waves. Now imagine these were roads and you were driving a car through these lanes. Now, as you come to a curve, what does your car do? It slows down. Well, the winds also are going to slow down as it goes over the curve. Now, when it straightens out, you're going to speed up. Again, when you get to the curve, you're going to slow down. Straight, you're going to speed up. Okay, I want to kind of get that in your mind. Think about that. Because next we're going to start talking about convergence and divergence. All right, let me go back to my other slide. All right, go back to our surface highs and lows. I'm trying to piece all these pieces together for you. For a low pressure, remember it's sucking air in at the surface. Winds are going towards our low. Well, you can't just continue to have air push into one spot or you'll end up with high pressure. It's got to go somewhere. So once it comes in, it starts pushing air up. All right, so with low pressure, it pushes air up. Now again, remember we need that rising air to make clouds. And then as a result, we'll end up with precipitation. That's why stormy weather and precipitation is more associated with low pressure areas. So air comes in and it has to go somewhere, so it goes up. Once it reaches the top of the troposphere, remember the tropopause, that area where the jet stream's going, it can't continue to go up anymore. It's that temperature inversion that it stops it. So once it gets up there, again, it's got to go somewhere. It can no longer go up, so it starts going out. That's divergence, when air is splitting ways, it's getting less dense, it's going somewhere else. All right, with the high pressure, you got just the opposite. Air is being pushed out by the high pressure at the surface. It's got to come from somewhere, and so it makes air sink down towards a high pressure. So, as a result, it pulls air in at the top of the troposphere. That's our convergence. It's coming together, and then it goes down to the high. All right, that is going to come into play when we get into our mid-latitude cyclones. Now, I'm going to do another video with that later on, but that gets you some main tips, and we're going to continue to build on that. So, let that sink in, and I'll see you again soon.